On Class A commutation using multisim. What is commutation? The process of turning off the conduction of the thyristor is called as commutation. Types of commutation. Basically, there are two types of commutation: current commutation and voltage commutation. The methods of commutation are natural commutation and forced commutation. Natural commutation. If the source voltage is AC, the SCR goes through a natural zero and a reverse voltage appears across the SCR. SCR is then automatically turned off due to the natural behavior of the source voltage. Forced commutation. This is applied in the DC circuits where commutation is achieved by reverse biasing the SCR or by reducing the SCR current below the holding current value. Here the commutation elements such as capacitances and inductances are used for the commutation purpose. Methods of forced commutation. There are 5 methods of forced commutation. Self-commutation, also called as load commutation and class A commutation. Resonant pulse commutation, also called as class B commutation. Complementary commutation, also called as class C commutation. Impulse commutation, also called as class D commutation. External pulse commutation, also called as class E commutation. This is a type of forced commutation and an example for voltage commutation where SCR is turned off by taking the SCR voltage below a particular level of voltage so that SCR will turn off. Here we are forcefully turning off the SCR, hence the name forced commutation. This is the circuit diagram of class A commutation. The working of this circuit can be analyzed using multisim. Source and V1 is the source used to trigger the SCR. Two channels are taken from the CRO. The first output gives the voltage across the capacitor and the second voltage gives the voltage across the SCR. Third, anode current flows and charges up the capacitor. The RLC forms a second order underdamped circuit. The current to the SCR builds up and completes a half cycle. The inductor current will then attempt to flow through the SCR in the reverse direction and the SCR will turn off. The capacitor voltage is at its peak value when the SCR turns off and the capacitor discharges into the resistance in an exponential manner. The SCR is reverse biased till the capacitor voltage returns to the level of the supply voltage V. It is an RLC circuit. The current in the circuit is sinusoidal in nature. The second waveform is the capacitor voltage. The voltage across the capacitor is twice the supply voltage at the time of turn off of the gate. The last waveform is the voltage across the SCR. Waveform on the CRO. This is the voltage across the capacitor and this is the voltage across the SCR. When the SCR turns off, the capacitor across the voltage is twice the supply voltage. Replaced by SL, capacitor is replaced by 1 by CS in series with the voltage source VC of S. Circuit, simplifying the expression and then applying Laplace inverse, the value of current was found to be I of t is equal to V minus Vc by L omega into e to the power minus delta t sine omega t, where V minus Vc by L omega is the peak value of current. Time of turn off. By applying KVL to the original circuit, that is Vc of t is equal to V minus IR minus LdI by dt. By neglecting the resistance and considering the initial voltage across the capacitor to be 0, minus V cos omega t. At time t is equal to pi by omega, that is at the time of turn off of the SCR, the voltage across the capacitor is found to be twice the supply voltage.